This video discusses triangle similarity, and these three definitions we have at the top are like the three main similarity theorems or similarity tests that we use to decide if two triangles are similar. So the first one is if two angles of one triangle are congruent, and congruent is another term for the same as. So if two angles of one triangle are the same as two angles of another triangle, then those two triangles are similar. Now, this is actually pretty intuitive because if all three angles of both triangles are the same, then the two triangles have to be similar. But if two angles of one triangle are the same, then all three have to be the same because the angles of a triangle add up to 180 degrees. So if two of them match, then the third one has to match. So even if you only know two angles that are the same, you can assume that the third angle is also the same. So if you can show that at least two angles are the same, then your triangles are similar. Another one is side, 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 and if the three sides of one triangle are proportional to the three sides of another triangle. So proportional meaning, say, if we look at these two triangles, well, actually, let me just draw a couple so you can see. And I'll call this X, Y, and Z. I'll name my sides. And I'll draw another triangle that I'll call A, B, and C. In order for these triangles to be proportional, X over A has to be the same as Y over B has to be the same as Z over C. So it doesn't mean the sides are the same. It means that the ratios of the sides are the same. So that's like the definition of proportional. And then the last one is, let's say we only know two of the sides, but we know one of the angles. So this only works if two sides are proportional. So say I have these two sides of a triangle are proportional, and this angle is the same. It has to be the angle, so if I have this side and this side are proportional to this side and this side, and I know these two angles are the same, then they have to be similar. However, if it's not the included angle, so let me draw two more triangles, and I know this side's proportional to this side, and this side's proportional to this side, and it's this angle that's the same, then that's a no-go. They might not be similar. And the reason for that is this triangle could look like this. Like, let's say this triangle looked like this. A is still proportional to Z, Y is still proportional to X, but knowing that these two angles are the same, well, these triangles are obviously not similar, right? These two angles are not the same. So it has to be that included angle is the same in order to show that the two triangles are similar. So let's look at a couple of examples to kind of help us see what it looks like when triangles are similar. So the first one shows that this angle, so this sine, since these have two lines and this has two lines, means these two angles are similar and these two angles are similar. So then I can say, yes, these are similar, and I know that because of the angle-angle theorem. At least two of their angles are the same, so I know they have to be similar. And then I will often want to write a similarity statement from there. So say I say triangle, and if I want to call this triangle ABC, is similar to, so I'm going to use this symbol for similar to, I have to say my triangle in the same order. So in this one, I started with my double line, so I have to start with my double line over here. So triangle Y, then I went to this one, so then Z, then to this one, so then to X. So the order has to match your corresponding angles. This one, very similarly to this one, we can also prove are the same, but in order to do that, we need to find this third angle. So I know the 81s are the same, but this is 60 and this is 40, so I need to figure out if these angles are the same. But I can do that because I know that triangles add up to 180 degrees. So if I start on triangle ABC, and I do 180 minus 81 minus 60, this is 39 degrees. If I do that same thing with my other triangle, 180 minus 40 minus 81, this is 59 degrees. So I have one angle that's the same, my other two angles are different. So no, I cannot say this triangle is similar because it doesn't have two angles that are at least the same. But I did need to at least try and find that third angle to make sure before I just said, no, they're not similar. Then our next one, we don't have any, well, we have one angle measure, I should say. Sorry, I shouldn't say we don't have any angle measures. We do know these two angles are the same because they both have this right angle. So if the sides are proportional, then I can use side angle side. Now remember, if I didn't have this included angle, if I had this angle, that would be a no-go. It has to be the included angle. So now I just need to see if my sides are proportional. So if I put 3 over 6, I need to make sure that is equal to 4 over 8. So if I simplify 3/6, that simplifies to 1/2. And if I simplify 4/8, that simplifies to 1/2. So these are proportional, so I can say yes. Because of side angle side, I know these are proportional. So I'm going to go ahead and name these triangles so that we can practice writing our similarity statements. So if we call this ABC and XYZ, when I write my similarity statement, then I'm going to say this is triangle, if I'm just going to go with ABC, because that seems the easiest, is similar to, now I have to make sure I go in the same order. So I started with my right angle, so start with X. And then these two sides were proportional, so then I go to Y, and then to Z. And then my last example, with pictures at least, has 3 side lengths. I don't know any angles. So in order for me to say that this, the only possibility I could use on this is side, side, side. If all 3 sides are proportional, then I can say, yes, these are similar. So it looks like these are drawn sometimes, like, for example, when we looked at this first one up here, they're not drawn with the same orientation. Like this one is this one flipped on its side, but it doesn't look like that's the case here. It looks like they're drawn similarly. So I'm going to go ahead and assume that they are to try it. So I'm going to map my 18 to my 22. So 18 over 22, and then set that 16 over 20 and 20 over 25. And this one is a little bit trickier to simplify. You could definitely do it, but I'm going to go ahead and just put it in a calculator. So 18 divided by 22 is 0.81, 81 repeating. And then 16 divided by 20 is 0.8. And 20 divided by 25 is also 0.8. So these two sides are proportional. However, this one doesn't quite hit the mark. It's close, but not quite. So this one, I would have to say no, is not similar. So then we're just going to go through a couple of questions to kind of make sure we understand what we need to know for triangles to be similar. So decide if the following triangles are similar, not similar, or there is not enough information, and explain why. So the first one is the 3 angles of triangle ABC are equal to the 3 angles of triangle DEF. Well, this one I can say yes, these have to be similar because at least 2 angles are congruent or are the same or are equal. 2 angles are congruent. And if at least 2 angles are congruent, then I can say that it's similar by the angle-angle test or the angle-angle theorem. The second one, 2 sides of the triangle ABC are proportional to 2 sides of triangle DEF. Well, if I go through my theorems, the first one was angle-angle. I don't know any angles, so I can't use that test. My second one was side, 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 which I can almost do. I have 2 sides and 2 sides, but I'm missing that third side, so I can't use that test. And then the last one is side, angle, side, but I don't know any angles. So this one, there's not quite enough information. I would either need to know one more angle, the included angle, I should say, the included angle, or the third side. If I knew those, one of those 2 things, then I could tell if they were similar. But because I don't know them, I don't have quite enough information. And then the last one is 2 of the angles of ABC are equal to 2 of the angles triangle DEF. Now this one is just fine, similar, because all you need to know is this at least 2 angles are congruent, just like we wrote right up here. And then we can use the angle theorem. So then this next question, if 2 triangles are similar, how do their angles relate? Well, as we learned from the angle-angle theorem, their angles end up being the same, because if 2 angles are the same, the third angle has to be the same. So the angles are the same. And then how do their sides relate? Well, as we learned in the side theorem, all 3 sides are proportional. So they don't have to be equal, do have to be proportional. And then the last question, what information could you have to know 2 triangles are similar? Give at least 3 possibilities. Well, I could know that 2 of their angles are the same, and that would be good enough. I could know that all 3 sides are the same, and that would be good enough. I could know that a side and the included angle and the side are the same, and that would be enough. I could also know that all 3 angles are the same, and that would be enough. Or I could know that all 3 sides and an angle are the same. So these are like the minimum of what you need to know, but you could have even more information and figure out that 2 triangles are similar.